We've all seen it. The code is clean, the tests pass, and the syntax is flawless. But the second a user actually touches the app, the whole thing breaks. Imagine you're building a project management tool. A user marks a task as done, but on their screen, the status instantly flips back to pending, then to done again, flickering like a broken light bulb. Behind the scenes, your user interface, background runner, and notification system are all updating that exact same status simultaneously. The system panics. It fires off an email celebrating a finished project, even though the task is actually still pending. Trying to fix this turns into a nightmare. The front-end team blames the backend. The backend blames the notification service. And they are all technically right. Their individual modules are written perfectly. When different modules argue over the status of a task, the code isn't the problem, the architecture is. You are seeing the direct result of a system built without one authoritative source of truth. To fix this, we have to establish a strict rule. Every important piece of data in your system can only have one designated owner. Let's look at how your bank handles your checking account. A banking application has marketing trackers, many email senders, and analytics tools. But they would never let the email service directly subtract $5 from your core account balance. Yet when we build everyday applications, we do exactly that. We drop in a brand new feature and let it directly rewrite core domain data whenever it wants. Ownership means one specific service, and only that service holds the authority to write to a dataset, validate the inputs, and define the rules. If a module doesn't own the data, its only architectural right is to read it, react to it, or politely ask the owner to change it. The immediate pushback from developers is usually about speed. If every request has to go through one strict owner, the application will lag. We separate the official source of truth, the primary database, from derived views like a local cache or search index, used strictly for faster retrieval. Downstream copies are necessary for performance, as long as they never try to act as the authority. If a local cache decides to update a task status on its own without routing the update through the primary owner, different users start seeing different versions of reality. Data duplication and aggressive caching only work when the entire architecture agrees on exactly which database holds the ultimate tie-breaking truth. Before you write a single line of code, you have to map out exactly how these data rules will work in practice. This process is called entity modeling. An entity is a core business object, like a user, or a project, or a task. Modeling is how you identify these objects and define exactly how they relate to one another. Once you have your entities, you draw a clear line around them. This boundary isolates the internal logic you control from external systems, like payment gateways. If a payment provider crashes, your core entities remain untouched, and the application stays online. This is especially critical when coding with AI. Large language models will naturally try to write validation logic in your front end, your background workers, and your database. You have to explicitly prompt the AI to respect a single data owner. When ownership is strictly enforced, scaling becomes a simple mechanical problem. You can build heavy caching for dashboards that users read constantly, without slowing down the core databases where real-time edits are written. Senior designers don't start by choosing a framework or a database. They begin by asking, who is the authority, and building a system that accepts only one answer.